Alright, so let's see this particular question now. Product of array except self, right? So in this particular question, we are given an array, and what we need to do is we need to build a new array where each element is actually the product of all the numbers in the input array except for the one which was present originally at that index in the original array, right? So what I mean is that, for example, if this is my input array 1, 2, 3, 4, right? So then I need to come up with an output resultant array in which, at every index, I would be having the product of all the numbers in this particular input array, except for the number which was present at that particular index in the original array, right? So for example, if you see over here, I get 24. Why? Because product of all the numbers in this particular input array, except for the number at that particular index, is 2 into 3 into 4, that is 24, right? Similarly, at this particular index, I would get 1 into 3 into 4, I would be ignoring 2. Right? So I would be getting 1 into 3 into 4, which is 12, right? Now at index equal to 2, I have, 1 into 2 into 4. That means I will get 8 over here, right? So all the numbers, product of all the numbers except for 3, right? Similarly at 4, I will have product of all the numbers except for 4, which will be 6, right? So now my output on my resultant array would be 24, 12, 8, 6, right? So this is going to be my final output, right? But there is just one very important constraint that we have to keep in our mind, that we are not supposed to use a division operator over here while solving this particular question, right? Without using a division operator, we have to actually build this output array using this input array, right? So this is the question entirely. Given an array ARR of n integers, construct a product array res such that res of I is equal to product of all the elements of ARR except for ARR of I, right? That's the relationship between the input and the output, and that's what we need to do, right? Now maybe you can just pause this particular video and try to think of a solution, and once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, see what we can do is we can actually construct two more arrays. One would be the prefix product array and another one would be the suffix product array, right? That, for example, if this is my original array 1, 2, 3 and 4, right? Now I will be building a prefix product array, and by prefix product array, what I mean is I will be taking the product of all the numbers in the original array till my current index, right? So for example, at the first index, my prefix product would be just the first number itself, because there is no number before the first element, right? So it will be 1, right? Whatever is the number or in the original input array. Then it will be 1 into 2 at the second index, right? So from the start till the current number, I will be taking the product of all the numbers, right? So at the second index or index equal to 1, my prefix product will be 2, right? Now at 3, it would be 1 into 2 into 3, so it will be 6, right? At 4, it will be 1 into 2 into 3 into 4, so now it will be 24, right? So this is my prefix product array, right? And now on similar lines, I will be building a suffix product array as well, right? And by suffix product, what I mean is it will be the cumulative product from the end of the array, right, backwards till that particular index, right, for whichever we are actually currently calculating the suffix product, right? So now if you see over here, so starting from the last index and going backward till that current index, I will be taking the product of all the numbers, right? So if you see at the last index, I just have 4, I don't have any number after it. So at the last index, I will be getting suffix product as 4 itself, right? Now when I go to the second last index, now I will be getting the suffix product as 3 into 4, so that will be 12, right? Then I will be getting 2 into 3 into 4, which will be 24 at this particular index, right? And then I will be getting 1 into 2 into 3 into 4, that is again 24 at this particular index, right? So this is my suffix product, right? So this is my prefix product, this is my suffix product. Now using these two, I will be actually calculating my resultant array, right? And how I would be doing that is that, let's take an example, right? So for example, I am calculating my value in the resultant array for this particular index, right? For index equal to 1, right? So what I'm saying is that at this particular index, I actually need to take the product of all the numbers in this input array except for this particular number, right? Which would essentially mean I need to take the product of all the numbers before 2 or before this particular number, and also I have to multiply it with the product of all the numbers after this particular number, right? So if I have product till here and I also have product of all the numbers after this particular number, then I can simply take these two values and multiply them together, and that will be my resulting value, which I can insert at this particular index in the resultant array, right? And that essentially can be actually taken out from the prefix product and the suffix product array, right? Because essentially the product of all the numbers from the starting till this particular index will actually be present in the prefix product array at this particular index, which is current index minus 1, right? So I can just take prefix product value at the current minus 1 index, right? And I can just multiply it with suffix product value at the current plus 1 index, right? Why current plus 1 index? Because now over here, if you see, if I want to take the product of all the numbers after this current index, that would be essentially present over here, because I have been taking the cumulative product from the end till this particular current index in my suffix product, right? So that means the value in the suffix product array at this particular index, right, which is 12 over here, would essentially be the product of all the numbers after this particular number, right? So that's why my strategy would be, sitting at any index, I just need to multiply the prefix product at the previous index with the suffix product at the next index, right? And that would essentially give me product of all the numbers in this particular array except for this current index number, right? I hope this is clear, right? So that's it. Now if you see the resultant array, 24, 12, 8 and 6, right? And we can even backtrace it. Now if you see at 1, we don't have any prefix, we will only have suffix, and suffix at the next index would be 24, so I get 24 over here. That means I'm saying that except for this particular number, product of all the other numbers in this input array is 24, which is right? So I will take just the suffix product at the first index because there is no prefix at the first index, right? Now once I move to the second index, that is index equal to 1, right? I will take the prefix product at index equal to 0 and the suffix product at index equal to 2, right? So that will be 1 into 12, right? So that's why I get 12 over here, right? Now at index 2, right, I will take the prefix product at index equal to 1 and suffix product at index equal to 3, right? So that would be 4 into 2, and now that comes out to be 8, right? And now again at the last index, I don't have anything in my suffix product now. This is my last number. I only have prefix product. So I will just take the prefix product value as is, and that will be basically my result at this particular index, right? And that will be 6, right? So in that way, I will be building this output, this resulting array, and this is what I will be returning in the end, right? So I hope this particular solution is crystal clear, why we are building prefix product array and why we are building suffix product array and how we are using them to actually calculate the resulting array, right? And also like what is the definition of prefix product and suffix product. I hope all of these things are clear to you now. And now talking about the time complexity and the space complexity. So now see, in case of time complexity, we are actually looping over this particular input array twice to actually build my prefix product and the suffix product array, right? So I will be having my individual for loops to building these two arrays separately. So it will be 2 for loops, but they will be in sequence. And then finally, I will be looping over this particular array again to calculate my final resulting array, right? So I will be having 3 for loops, right, in sequence. So it will be order of 3 multiplied by n, which will be nothing but order of n itself, right? It will be linear. So the time complexity of this particular solution will be order of n, right? And talking about the space complexity, over here we are actually constructing 2 extra arrays for holding my prefix product and suffix product, right? And so my space complexity will also be order of n, right? So that is the time complexity and the space complexity. And now let's see the code for it. Alright, so now let's code the solution that we just discussed. To start with, let me just declare a function, product except self, something like this, right? And this function will basically accept an input array, right? And that's it. And now what I can do is, to start with, I will just capture the length of this particular input array in a variable n, right? Also, I will just initialize a variable to calculate the cumulative product and I will initialize it to 1, right? Because see, I have to actually use this particular cumulative product to calculate my prefix product and the suffix product array, right? I will be going from the left to the right in case of the prefix product array to basically get the cumulative product at every index. And similarly for the suffix product, I would be going from the end till the starting to calculate all my cumulative products at every index from the end of the array till that particular index. So for that, I will be using this particular prod variable, right? And I will now initialize it to 1, right? Now what I will do is I will just declare my prefix product array, right? I will just name it as pre_prod, right? And I will just initialize it with all zeros of size n, right? With n zeros basically, right? And then I will also have a suffix product array. I will just call it as suff_product, and this also I will just initialize with n zeros, right? And finally I will also declare an array of n zeros to hold my resulting array that I have to finally return, right? So this will be my resulting array that I will be returning finally. So those are the variables that we have declared. And now what I will do is I will be calculating my prefix product array, right? And for that, what I will do is I will just run a for loop for I in range n. That is, I will be going from the start till the end, from 0 index till the n-1 index. And what I will do is I will keep multiplying the current value of my prod variable with the current index that I am at, right? So this way I will keep building this product till the current index from the starting, right? And now what I will do is in the pre_prod array, that is the prefix product array, I will just initialize the ith index with this new product that I calculated at this index, right? So this will essentially have the product of all the numbers from the starting till the current index, right? That is the meaning of the prefix product array, right? And now the similar thing I would also be doing for my suffix product array, right? I would be doing the same thing, just that I will be iterating from n-1 index to my 0th index in steps of -1, right? I will be going in reverse now, right? And I will be doing the same thing, and over here I will be assigning to my suffix product array like this, right? And also I will just, before running this particular for loop, I will have to actually reassign my prod variable to 1 again. I will just reuse the same variable, right? I don't have to like declare multiple variables for prefix product array and suffix product array. I will just utilize the same product variable over here. And then again, now I will go from the end to the current index to calculate all the product of all the numbers till that particular index, right? So this is my suffix product array, right? And now what we will be doing is we will be calculating this resultant array, and the way we will be calculating it is that we will be looping over all the n elements, right, of the original input array, and at every index we will be actually multiplying the prefix product or the value in the prefix product array at the previous index with the value in the suffix product array at the next index, right? That's what we have discussed, and that will actually give me the resulting value or the product of all the numbers in the input array except for that particular element at the current index, and that's what I will just put in my resulting array at that particular index, right? So for doing that, what I will do is I will again have a for loop from 0 to n, right, like this. And in this, what I need to do is I just need to initialize my res of I, that is the element at the current index, current value of I, with, you know, the prefix product value at I-1 index into suffix product value at I+1 index. That is the next element, right? That's what I will keep doing at every index, right? And finally, I will just return my res array, which will basically have the expected output, the desired output, and at every index I will have the product of all the numbers in the original input array except for the number which was originally present at that particular index in the original array, right? So that will be the output which will be present in res, and that's the expected output, right? And actually, before returning, I will also have to handle two corner cases. one would be for the first element and the other would be for the last element, right? So for the first element, when I'm actually populating its value over here, right, which is index 0, there will be no value for the previous index in the prefix product array, right, for index equal to 0, right, because that is the first index. So what I can do is I can actually handle that particular case separately, right? For 0 index, I will say that I only have to consider the suffix product array of the next index, which is index 1, right? That will be my value of the resultant array at index 0, and also for the last element there would be no value at the next index in the suffix product array. I just have to consider the prefix product array value at the previous index, right? So for that, like for the last index in the resultant array, I will be using the value in my prefix product array at the previous index, which would be n minus 2, right? So this will give me the desired output for index 0 and index n minus 1, and for the rest of the indexes I can use this particular loop. Just that I will have to modify my range to 1 comma n minus 1, right? This will be my range because now I just have to iterate from index 1 till index n minus 2, right? So that's why I will give n minus 1 over here, right? So this is going to be my final code now. This is the entire solution. And again, just reiterating on the time and the space complexities. Now if you see, we are just using 3 for loops over here in sequence. So that means the time complexity will just be order of n, right? And space complexity, we are just using 2 arrays over here of length n. So that means the space complexity will be order of n. So time and space complexities both will be order of n over here, right? So this is the entire solution. I hope you understood it well. And now I will see you in the next video. Thank you.